As announced a while ago, I have received a quite big lot of HP instruments, and there are in very different conditions one each other. This one seems that somebody has already started to work on and then gives up. So this is the 5335A universal counter, and I've been told that the unit was working, then suddenly something happened in the input circuit, and hopefully nothing related to the chip here. Here we have a push button that I already have fixed. It has been a very big challenge. Well, the person that gave me these things told me that while I was attempting to remove the push button, he suddenly stripped the small finger that is inside that make the push button to be held in the push it position. So I repaired it. I have all the parts, so this is to be reassembled and tested. By the way, he told me that the counter is very unstable, so I know that this can be because of the input adjustment, and for that will be very helpful my old oscilloscope over there, the 1745A, which is very sensible in the input. And this is what actually has required in the service manual. By the way, I will go ahead to the next instrument, and this is something that I had here in the lab since a while. I never switch on, and it's part of the lot, but I immediately put here in the lab. This is an 8903E distortion analyzer. It's a very handy instrument to perform such audio equipments adjustments. And since I'm going to receive a very interesting and large project about Pioneer equipments, I wish to go ahead and try to fix it if it can. The unit has been told that the unit was perfectly functioning, very precise, but then doesn't power on anymore. So perhaps we have some blown up fuse and things like that. So let's go ahead with this first. I will put the frequency counter aside and we will go from there. Okay, let's start with the fuse. And I already have seen something strange here. Yeah, the fuse is blown. There is a clear mark here. And it should be 1 amp. So let's take the ohmmeter. And yeah, meter confirm blown fuse, and it is rated at 1.5 amp, so it is the 120 volts. Okay, so let's open the instrument. Okay, so while I was removing the screws, I was thinking, would it be reefer cap? These are very prone to fail in these instruments. There was largely used, so hopefully it is something like that, but I already have seen that there is a filter here that is built in the plug. So I'm afraid that we are having the filter caps inside the plugs itself. Hopefully not. So let's go ahead with some check. Well, I made some static tests and nothing is wrong. All the fuses here are good. Capacitors seems fine. And inside this filter seems that there are no capacitors, but I really doubt it. If we look at the schematic, okay, they are just on the top, and the load indication. Well, what I tested, and there is no shorts nor in the input, neither in the output. So there is something that I suspect that has shorted and eventually opened the capacitor inside the filter, because I'm not reading any leakage. So I have installed the 1 amp fuse and connected to the variac, and let's try to power it up. So let's see if the front switch is on. Should be, since yes, is on. So let's rise up the voltage while we look at the fuse, and hopefully we will not see any strange lightning in the fuse. So yeah, I'm already at 120 volts, so if something was wrong, I should have seen I heard something. Well, I am at 200 volts. Oh, would you look at that? It's working. Here we have also here some LED. So let's see the front panel. Yeah, it's working. Oh, that is very nice. So it seems a very easy repair. So let's try to switch off and connect directly to the line. Okay, so I have plugged it directly to the line and it's working. That is really fine, and clearly the fuse has blown. Actually, it wasn't really badly blown up. So perhaps it has been tried to power it up after a very long time sitting somewhere, and the capacitor should have been reformed slowly. So since I have cranked up the variac slowly, I think that has reformed the capacitors. And as we can see, we are reading clearly something, and this instrument is very useful since it's an AC voltmeter. You can read DC level, so for especially for audio power amplifiers as well as tuners, it will be very handy to have this instrument and check the characteristics of the unit under test. So let's go ahead with some cleaning refit the covers and make some tests. Well, I will say that unfortunately this unit has the rack mount option that include the rear input connection, so we don't have any front panel connection. There are also some fingerprints here, so it's quite annoying to have this input system. By the way, we have two different inputs here that I still don't, they are labeled low and high, so don't know if it's related to volts. Yeah, this is 42 volts peak maximum, and this is up to 300 volt RMS, 100 kilo ohm. Both channels here, both inputs has 100 kilo ohm impedance, I believe. And this is the 600 ohm monitor output, so we can plug to an amplifier and a speaker and hear the actual signals that is fed in the instrument. So since this, I believe it's for high power amplifiers. By the way, I will feed some signal here from an external signal source and see if it reads correctly, or at least close to where it should. Well, just for curiosity, we have a Motorola sign here, so I believe that this belongs to Motorola Labs somewhere around the world. Okay, I'm feeding 1 kilohertz minus 10 dBm, and it's reading minus 14.7, but I have a very long cable, so I think there is something, some attenuation because of that. And if I'm going to measure the distortion, I'm having, okay, removing the weighting, 0.07%, and I'm not sure that this is okay. However, it's reading and it's working to some extent. Let's try to switch off the output. Looking at the service manual, it seems that needs some special instruments like AC calibrator. However, it is required to check the input flatness and the AC voltmeter reading. So I'm having 3.51 volt RMS, and on my scope, which I know is well calibrated, I'm reading exactly the same. So this instrument, I've been told that it was pretty accurate, and it seems indeed that it was, and it is also. So I don't want to mess anymore with calibration right now, and I want to test more in depth with some other instruments. So yeah, I will say that the instrument is fixed, and if I will find some something to be adjusted, I will perform the full calibration later on. By the way, as I was thinking, the rear connection is quite annoying, so if I will have any chance in the future to find a front panel with connection, I will replace it. But since that, I'm having a good distortion analyzer, so I can go ahead with the audio projects for the incoming audio projects. So Let's go ahead with the counter and see if we could have some lucky as well. So this is how the inside of the counter looks like. I already have mounted the push button here, so time to reassemble it. Well, I found that the front panel actually were disassembled, so all the screws were removed. So I've partially reassembled this unit. I just fit two nuts here, and yeah, I want to check first if everything is fine before to go ahead and install everything. So let's finish to connect the electrical connection and the RF cable here, and then let's see what it does. I have temporarily reassembled the board and connected all the wires. I've just fit two bolt here. I have plugged it in, so the instrument is powering on. Clearly no displays. So let's apply some signal here and see what it does. Well, I'm applying 50 millivolt 1.5 megahertz, and it's reading almost perfectly. On the other frequency counter, it's bouncing a bit the last digit, which is exactly this one. So perhaps my signal generator has a bit of drifting or bouncing, I don't know. By the way, both of the counters here has the oven oscillator, so it's just 1 or 2 minutes that they are on, so perhaps they have to stabilize. So let's run it a bit at this point with this condition and see later on how it behaves. Well, it's quite a bit that is they are running, I mean, and they are behaving the same manner. I'm checking right now the 10 megahertz output of this one, and as you can see it's a bit high, so I think should be adjusted. I will wait a bit more, but it's already in temperature for sure. I have not checked yet this, so let's do it right now. Well, it seems good so far. Frequency C, and it's going from 150 megahertz. So frequency 150 megahertz. Let's see. Okay, here it seems that there is a lower sensitivity since it's not able to reach the let me increase the amplitude to 100 millivolt, and yes, with 100 millivolt it is able now to read. Still a bit lower, but seems fine. Okay, I've been able to fine-tune the oscillator and it is spot on, and I'm feeding signal on both, and indeed we have a bit of bouncing on this fourth digit that we don't have here. So here we have a more stability, This may be caused by the signal generator. I'm feeding 100 kilohertz, so hertz, these are millihertz, so 600 millihertz, and it's moving in the range of tens of millihertz. But here it's bouncing in hundreds of millihertz. So I suppose that the inputs maybe need a tuning, an adjustment. So I think we'll perform the full calibration and see if can improve any further. Well, at the very first step of adjustment, the instruments start to fail, and it gives me an error, fail for 4.6. But it's happened that it seems that we have a very weak connection here. There is something that maybe oxidated. So after wiggling a bit, as you can see, I don't have any much fails, but I need to fix that. And by the way, the adjustments is required to be exactly 3 volts plus or minus 20 millivolts, and it was 3.150 millivolts. So it seems that has been regulated high since in the procedure here put the instrument in a dialogue mode that itself read the DC voltage, and on the display we should see 2.985 plus or minus 15 millivolts, and in 50 millivolts, and indeed it's reading 2.92, so it's a bit low, but still I think no, it's out, so need to be addressed. Perhaps the weak connection there is causing that. The removal of the plug revealed this bent pin. I don't believe that it's the cause, but not good to see. So this is the bottom, and I decided to reflow also the pins. Seems a bit weak, those solder joints, and clearly somebody has been in before me. Over there are some flux residues, so I will clean them up and close and try it again. Okay, with voltage set exactly to 3 volts, I am now very close, 2.984,983, so it's well within 50 millivolts. So the cleaning and reflux fixing the problem. So let's go ahead with the adjustments. Well, I went to another grade of precision and still within spec. Very good. Well, I eventually been able to use this to calibrate the input of the frequency counter, and indeed it works. So it is requested to use as X and Y. So to center the dot like that, then put in DC mode and center the gap here, and the dimension should be 2 divisions since it's 20 millivolts. So it worked pretty fine, and even they are a bit touchy, the adjustments, they respond very well. Really happy. I have moved the connection to channel B, and it is way off. Look at that. completely misadjusted. Yeah, I think it's a quite complicated adjustment is. So in the past maybe they have just triggered a bit without any instrument connected. Second channel, spot on, very good. Continuing the process of calibration on channel C, which is the 1.3 gigahertz input channel, is required to perform this adjustment, and I should read 1.010 gigahertz. Completely out also this adjustment, so hopefully this will improve the precision of the instrument. Okay, I will consider that acceptable. It's okay, it's almost 100 times more the precision that it is required, so I can go ahead with the calibration. Okay, the calibration process is finished. The instrument reacts pretty fine, and it's very sensible. It's required to in channel C to be able to read down to minus 24 dBm, which is right now here, dBm minus 24, which means plus 14 millivolts, which is very low level signal, and it's very stable. So I really like it. It's a very nice instrument. So I will test it more in depth with another instrument that still need to be repaired and finished. However, it's nice to see those two instruments, this and that, back in business. So in the future, hopefully we will see them troubleshooting, using them to troubleshoot some instruments. So thank you very much for watching. Hope you have enjoyed it, and see you soon.